You got to the bare metal, ready with your tools to communicate heart to heart, but oh no, there are no UART ports to be found. Now what? Well, UART, also known as Universal Asynchronous Receiver Transmitter, is a communication protocol that can be found on most embedded and IoT devices. And it is without a doubt, whether you're an engineer, hobbyist, or a cybersecurity professional, that you should know how to figure out where these ports are, especially as nowadays these manufacturers of consumer grade electronics are not providing proper labels. I'm Ayushman, and today let's dive into this topic. Now, before we begin, special thanks to DevHawk for the creation of this video. UART, as mentioned before, is a serial line communication protocol found on many consumer-grade devices. These can be used by both engineers, hobbyists, and especially the third kind, which is us, the cybersecurity professionals. However, nowadays, UART ports, which are used for the protocol, are not clearly labeled on consumer-grade devices. This is done by manufacturers to limit hobbyists for flashing their own versions of firmware, and for cybersecurity professionals from dumping their proprietary resources into our own USBs and laptops and so on. So it is up to us as hobbyists, engineers, and cybersecurity professionals to wrap up with our multimeters and figure out which of these ports are what. To be clear, UART has 4 ports, namely the ground port, which can be labeled as GND, the transmitter port, which can be labeled as TX, the receiver port, which can be labeled as RX, and the VCC port, which is used to supply a voltage, usually 3.3 volts or 5 volts. These contact areas, which could be in the forms of headers, pins, holes, or they might not be labeled at all and are just copper pads, have to be using something known as a serial to USB converter. This could be an adapter, it could be an Arduino, and it could be anything else that might be present. Now, where the issue is, as mentioned before, is that manufacturers are no longer labeling them. So how do you figure out which is which? Well, we can do that using these following tools. Firstly, a multimeter. This will be required to check both the continuity of the pins and to check the voltage. Next would be jumper cables to allow us to connect to these pins, especially if they are of the type of holes or header pins. And finally, a UART to USB or a TTL to USB converter. Now, without much ado, let's get into it. Well everyone, all the tools that we discussed before are laid out in front of you. Here we have a digital multimeter, the jumper cables, the USB to TTL adapter, and finally the motherboard on which we will be testing for the UART ports. Now, in case you don't have the USB to TTL adapter but you do have an Arduino, well, this too can be used as a USB to TTL adapter. You can find more information online. Otherwise, basically it has a chip which is the 80 mega chip, which allows you to convert USB to serial data, and also has the RX, TX and ground ports that will be utilized for the UART connections in 99% of your devices. Now, this multimeter that I got from Amazon costed me 200 rupees. Without a doubt, as it's very cheap, there might be some inaccuracies that will hamper our journey into figuring out the UART ports. Therefore, what I like to do is test all of the variables that will be required to be measured against something for which I already have the values. On the multimeter, you will find multiple symbols, which will be the multiple modes and multiple different variables that you can test. What will be utilized for us will be number 1 is this. The V sign with 2 lines, one dotted and one continuous. This will be utilized for measuring the voltage between pins. And one at the bottom right corner in my multimeter, which has a Wi-Fi symbol and a diode symbol. This will be used to test the continuity, mainly used to find the ground pin. What I'm going to do first is to shift my mode to the continuity mode. So I'll go till here. The arrow is pointing towards the Wi-Fi symbol, and what I'm going to do is just touch the probes against each other. There's a beep that means that the entire signal is continuous, the connection is continuous, and voila, I have my connection. If I want to be even more precise, what I can do is take one of these. This is a blade fuse from my car, and in your car's fuse box there are multiple similar fuses, and these fuses are spares in the car. So what I did is take one of them. I'm going to place them over here. Again, take one probe, place it on one end, take the other probe, place it on the other end, and we have a sound. Why? Because both of these probes are connected through the internal wire, hence they're continuous, and we had continuity. Now, the other thing we need to test is the voltage. So what I'll first do is go to the voltage mode. In my multimeter, I have to set the range of measured voltage manually. So what I'll do is take the lowest range on my multimeter, which is 20 volts, as the actual voltage for which we'll be testing will be around 3 to 5 volts max. And in order to ensure that my voltage reading is correct, I've taken this brand new battery, which should have a reading of around 1.5 volts. I take one probe and I place it on one end, my other probe on the other end, and as you can see, my multimeter showcases a voltage read of 1.62, which is acceptable. So now that we are confirmed that our multimeter is in working order, what we'll do next is to actually find the probes. Now, this motherboard that I'm using has its UART ports clearly labeled, as you can see in the screen, in 3, 2, 1. Alright everyone, now we have changed the setup a bit to better make all of you understand the intricacies of what we are going to do. So, this is the motherboard that we'll be testing on. As you can see, all the UART ports are clearly labeled on this motherboard. Well, the reason for that is to verify that whatever we are doing is actually correct and would be reproducible when you guys actually get your hands on a consumer device where the UART ports are not listed. 80 to 90% of the times, the devices you will get your hands on, like I said, the UART ports will not be listed, due to which we are conducting this exercise in the first place. Well, now, first what we'll do is test the ground port. The ground port is labeled on the motherboard, and for that, we'll use our multimeter in the continuity mode. In my multimeter, the continuity mode is shown by this symbol of Wi-Fi, which is for the beep or the diode symbol. And what I'll just do is take these two probes. I'll put one probe on the ground port and another port on any other metallic area which can be considered as ground, or which is actually the ground of that motherboard. Usually, the shield around a SIM card reader or a USB port or your power adapter, etc., is actual ground. So you could use those as a reference, and that's what we're going to do right now. We have the shield of the SD card over here, which we'll use as a ground reference. So one probe on the UART ground port, other probe on the shield, and as you can see, we got the beep and we have the beep. So there's continuity. That means that that is indeed the ground port. So we verified the ground port. Whenever this actually comes in real life where you won't have the UART listed, you will go through each port one by one, and there will only be one port out of the 3 or 4 ports which would give you continuity with a reference ground. Now, one thing that you might note is that there's no VCC over here, and I said 3 or 4 ports. Well, a lot of the times the VCC is the power being supplied to the motherboard using the external power source. So they might not actually provide VCC through the UART ports. Now let's move on to the next part. Alright everyone, so previously we figured out which is the ground port. Now what we need to do is figure out which is the RX and TX port. Usually when you're trying to figure out which of the ports is RX and TX, you're going to look at the voltage fluctuation that it is receiving while the motherboard or the device is booting up. This is why I've connected the motherboard to the device it originally came from, and I've connected this device to the power supply over here, right, and the extension over here. And what I'm going to do is power cycle the camera again and again and check the value of the readings of voltage I'm going to get on my multimeter. Now, while you can do this method to figure out the RX and TX, what you could also do is, once you figure out which is the ground port, is just connect the RX and TX lines to the TTL reader you are using, and then just see if you get any output. So you connect the RX of your motherboard to the TX of your TTL, connect it to your laptop or your PC or whatever peripheral you're using, and use whatever you're using to read that USB to UART connection. Could be Picocom, could be some other thing, right? And via that you can see whether you're getting an output or not. If you do get an output, congratulations, you figured out which is the TX port, and naturally then the other port is going to be the RX port. And if you get no output, you can well switch the wires between the RX and TX until you actually get a reading. However, again, we can do this exercise, which we're going to do right now. So let's first figure out which is the RX port. So I have my probes over here. I have my multimeter set to 20 voltage reading. This is because the voltage that is usually supplied to such motherboards is between 1 to 5 volts. Usually 1.8 volts, 3.3 volts, or 5 volts. So 20 volts is the reading I set it to, maximum 20 volts. So I could obviously read 3 and 5. Now what I'll do is put one of my probes right on the RX port. I'll switch this on and quickly connect this to a ground. As we can see, we got a reading -3. It's fluctuating a bit. -3 again. Fluctuating a bit. And now what you're seeing is a stable voltage at around 3.35. The small fluctuations that are coming could also be because I'm speaking, so my hands are shaking a bit, and there could be certain disconnection like I did right now. Right. However, we can consider that the average voltage is going to be around 3.35. And usually when you're measuring the RX port, what you're supposed to get is during boot up or after boot up, you are idling at high. So 3.3 or 3.34 volts is what it is idling at. So we can consider that this is indeed the RX port. Alright, what you right now saw is that our 3.3 voltage was the average voltage that was high over here. And that indicates that this is a stable high voltage. We can say that this might be the RX port. However, the little fluctuations we did see right now could also point towards it being a TX port. So now let's move on and also see what readings we're getting with the TX port to better solidify which of the ports is actually RX and TX. So we're going to do the same exercise. I'm going to keep one probe on TX. The other probe I'm going to keep on the sheet of the SD card reader, as I know that it's the ground. Currently, I have not power cycled the camera, so I can see that my voltage is coming as -0.07. Negative is because I've used the opposite probes. If I just do this and again measure it, yeah, now it's positive 0.05. This could be considered as actually being held low. See, now we are 0.00. What I'll quickly do is power off, wait for 10 seconds, 1, 2, 3. Alright, and now I'll power on again. Quickly I put it to TX0 and let's see what we get. Constantly being held low. Again, we're seeing very minor fluctuations. Let's do this once again. We switch this off and we switch this on. Quickly put our ports over here. And we can see this is constantly being held low. Now, the TX port is the port that is being used by the camera to send data onto a USB TTL reader, and the RX port is the port being used by the camera to actually read data that it will be receiving. The RX port is being held constantly high, as you can see 3.34. The TX port is being constantly held low, 0.010, 0.09, and so on and so forth. Now, the thing that could be happening right now is that values are quickly being fluctuating on the TX port, which my current reader is multimeter is not able to actually calculate. It's showing the average voltage, and the average continuous voltage is coming out to be 0.0, 0.02, so on and so forth. With RX, we saw the average voltage being held high. This could allow us to actually conclude that, in fact, if it's being held high, the port is RX, and if it's being held low, the port is TX. Now, this is one way to figure it out using multimeter, which we did right now, the ground, RX, and TX. However, whatever behavior we saw on the RX and TX could be a little bit different across different motherboards. Therefore, the other method to verify it is that now, because we know that, okay, either of them is the RX and the other one is TX, just connect it to your UART to USB converter, TTL reader, and whatever port gives you the output on your PicoCom or whatever you're using as the serial reader software, well, that is indeed your TX port.